Hello, Charger family. This is Mrs. Boyd, Mrs. Boyd's Math Room. Today, we're going to talk about conditional statements. So not any computation is going to be happening today, but a whole lot of thinking and relating. So let's talk about what the hypothesis means. That is the statement after if. As in, if P happens, then Q happens. So let me scoot up just a bit here. So we can say it's like the hypothesis and the conclusion. So like if the battery dies, then your phone will shut down. If one thing happens, then another thing happens next. The conclusion is the statement after then. So if Q, then P. The hypothesis in this case and the conclusion are swapped. They trade places. So if the phone battery, if the phone, not the battery, if the phone shuts down, then the battery is dead. Okay, same ideas, we just put them in an opposite order. So that's conditional and converse. We have inverse. And we read the little squiggly line here as not. So if not P, then not Q. If not P, then not Q. This is the opposite of the hypothesis. And the opposite of the conclusion. So the little squiggle pretty much means the opposite. So if the battery does not die, then your phone will not shut down. Okay. Last one, the contrapositive. So if the opposite up here, Q then P, is the converse, not Q then not P is the contrapositive. And we say it, if not Q, then not P. It's the opposite of the conclusion and the opposite of the hypothesis. So with our phone example, if the phone does not shut down, then the battery is not dead. All right, let's flip your paper over and we'll talk about some examples of these. All right. Our conditional statement. If you live in New Jersey, then you live on the East Coast. The converse will tell us, let's figure out what P and Q are. P is if you live in New Jersey. Q is live on the East Coast. So the converse will be if Q, then P. If you live on the East Coast, then you live in New Jersey. Is that true or false? That is definitely false. There's lots more places on the East Coast that are not New Jersey. The inverse is going to be if not P, then not Q. So if you do not live in New Jersey, then you do not live on the East Coast. True or false? That is false. Like we just said, there are lots more places that are on the East Coast that are not New Jersey. So if you do not live in New Jersey, you could live in Maine and still live on the East Coast. Contrapositive. That one's going to be if you don't live on the East Coast, then you don't live in New Jersey. Well, if you don't live on the East Coast, then it's impossible for you to live in New Jersey. So that one is true. Let's do another. Scroll it on down here. If a polygon is a rectangle, then it is a square. So let's say P is polygon is a rectangle. Q, it is a square. The converse would be if a polygon is a square, then it is a rectangle. That's true. All squares are rectangles, but not all rectangles are squares. And when we say it in the converse, then it is true. The inverse would be if the polygon is not a rectangle, then it is not a square. If the polygon is not a rectangle, then it is not a square. That is absolutely true. Your polygon has to be a rectangle for it to even have the possibility of being a square. All right, contrapositive. If a polygon is not a square, then it is not a rectangle. That one is definitely false. We could have a rectangle that is not a square, and we often do. Just a few more so we can really get the feel for these. If two angles have a sum of 180, then they are supplementary. So P is two angles have a sum of 180, and Q is they are supplementary. Converse, if two angles are supplementary, then they have a sum of 180. Definitely true. Supplementary angles always have a sum of 180. Inverse, if two angles do not have a sum of 180, then they are not supplementary. Also true. If they're not 180, they can't be supplementary. And the contrapositive, if two angles are not supplementary, then their sum is not 180. Also true. These facts and definitions make it easy for us to see if these factual statements are right, these conditional statements. All right, last one. If two angles have a sum of 90, they are acute. Then both angles are acute. We'll do the converse. If two angles are acute, then they have a sum of 90. Definitely false. Our angles can be 30 and 20, and they're both acute, but they do not add up to 90. How about the inverse? If two angles do not have a sum of 90, then they are not both acute. Also false. Our angles don't have to add up to be 90 to be acute. They can be whatever they want to be. That's less than 90. Last one, contrapositive. If two angles are not acute, then they do not have a sum of 90. That's definitely true. If your two angles are not acute, if they're both greater than 90, their sum cannot possibly be 90. This is a little abstract today. This is definitely different than anything that we've done previously. I really hope it makes sense. I hope you understand the difference between these four kinds of statements. And I'm very hopeful that you'll reach out if you have any trouble. You know how to get a hold of me. Please take care of yourselves, and I hope to see you very soon.